Hey everyone, I'm Greg Jones for Engine Builder, and thanks for tuning in to another episode of Intellectual Horsepower. Today our topic is valves, and to help us talk all about valves, we've got some great people joining us in studio today. We've got Ryan Hamilton, he's President and CEO of SBI, and we've got Phil Data, he is VP of Sales for SBI, and of course we've got Drew Pumphrey, owner of D&J Precision Machine. Guys, thanks for joining us this morning. How's everybody doing?
Good.
That's awesome.
Thanks for having us.
Yeah. No, excited to talk about valves here today. Obviously, everyone's familiar with valves. They play a big part in engines, and it's one of the products you guys specialize in at SBI. So I just wanted to have a free-flowing conversation about the topic, and I wanted to start on maybe the negative side of valves, the problem side of valves. What are some of the things that you guys see folks complaining about, both at maybe the manufacturer level as well as the engine builder level, maybe in terms of, how those valves get made and some issues that you might have seen there, as well as when they're in the engine and under, harsh conditions and extreme conditions, what's some of that stuff that happens, and then we'll kind of work backwards through some stuff from there. So Phil and Ryan, I'll start with you guys on the manufacturer side. What are some of those things that you guys see day in and day out that you guys are working to perfect and, not have be an issue?
Well, with modern technology and the ability to produce and manufacture valves, it's come a long ways.
Yeah.
Things of the past where you're dealing with run-out issues with stem to seat face run-out. That's where I think historically there was some room for improvement. But with the way we operate and partner with these manufacturers now, the technology has come so far to where you really shouldn't have to touch a face of a valve prior to installation. We keep a really good tight standard for that, and obviously check during the QC process to make sure that we've achieved that standard and call out. Outside of that, when you're dealing with the OEM and understanding what they've put in place,
Sure.
Ensuring that it's a good enough material, something that's really going to suit the environment in which it's going to be, placed under. You do see a few here and there that need to be improved upon. We certainly take it upon ourselves to upgrade those materials.
Yeah.
But for the most part, that ability to produce has really come a long ways.
Yeah. And I remember visiting you guys down there at SBI, headquarters. QC is a big deal. You guys take that serious, and I think it shows in the product, so that's great. Drew, how about over on the engine side? Obviously, you probably see valves get messed up every single day.
Yeah, we do.
Various things.
We see all kinds of different failures.
Yeah.
Just our engines, we primarily focus on the Cummins engines, the B series Cummins. So Cummins did a great job with that engine. We don't have like a common valve issue that some of the other engine manufacturers have out of the OE. So they've done really well. We typically don't see problems until we get the high horsepower stuff. So once you get to high horsepower stuff, you have issues with tuliping and just from the cylinder pressure issues and the extra heat. So, but for the most part, the Cummins engines do real well.
Yeah.
They did a good job with offering multiple levels of exhaust materials, whether it be a light usage, light duty, medium, and then the heavy. They made an array of exhaust valves that are all the same size, but meet the EGRs of the temperatures in which they're going to be, forced into by the usage.
Yeah.
Yeah. Some of the newer engine families, like Cummins got cheap in a cab chassis models, so we upgrade to the better alloys that was in the pickup trucks for the cab chassis trucks, because they are one of them that have issues. It was like 2011 up, cab chassis started to have problems with valves.
Yeah.
But other than that, the Cummins stuff has been real strong.
Yeah. Very good. Well, like I said, I wanted to start there because it allows us to discuss everything else about valves, right? Your materials, your sizes, intake versus exhaust. Is it a one-piece, multi-piece? There's all these different things at play that, you guys have to tinker with. And then, Drew, you guys are reporting back based on what you're seeing, at the racetrack or with guys driving, 300,000 plus miles and things like that. So let's start there with the materials and maybe some of the valve sizes involved. Ryan and Phil, do you guys want to talk about kind of what you guys do at SBI and what's in most of your primary, product of valves?
One of the big things, going back to the communication piece, that you were just saying, from what Drew or another one of our partners would see, is important to us because we have to understand the operating environment and how it's going to be used.
Yeah.
So when you talk about one of the Cummins trucks, then is it going to be somebody that's pulling a sled and is going to have this in a super harsh environment, or drag race? Is it going to be somebody that is, pulling a trailer, has a business? Or is this just kind of the daily driver that you see a lot of also?
Right.
So understanding what that environment is helps us start to trace back. Is this going to be one of our, is it a basic stainless steel? Is it going to be an upgraded stainless steel? Are we going to apply a surface finish to that? Are we going to nitride this? Are you going to get into a super alloy and maybe take this to, Inconel? So without knowing what you're trying to achieve or solve in a lot of cases, and that's where our best communication comes in with Drew, because Drew can accurately report, this is what I see, this is what the challenge we need to overcome, and then Ryan and his product team start to sit down to say, okay, well, this is what we can do to change this. And it's not always in the metallurgy, for that. So is it the metal? Is it going to be the dimension? Do we need to add a surface finish to that? So you'd be very surprised how well your traditional stainless steel, whether that's 21.4 end or 23.8 end, works well.
Yeah.
And whether you apply a nitride to that or we get into our upper end Inconel.
Yeah.
So there are a myriad of options.
Yeah.
But just trying to throw something in potentially over design as well isn't where you want to go. At the end of the day, Drew has a cost structure, and we need to be able to keep him competitive, with his customer, as he's not the end user. So you have to keep that in mind so that we have a piece that is still economical and profitable, but is going to work well.
That's a great point. Excellent point.
Yeah, you can't always charge $65 a piece for a valve. So you got a 24 cylinder head. It's just a lot of money, and there's a lot of customers that don't need that at all.
Yeah. So Ryan, I'll come back to you. Phil talked about a couple of those different material options. Do you guys do more on certain materials than others, or do you kind of run the gamut in terms of those options?
Certainly a gamut. With the accessibility to the super alloys, obviously it was a game changer. There are some other alloys out there that have been created to compete with the super alloys in Inconel or Pyromet, that are modified versions of stainless steel, or really good nickel content, nickel 30, that are becoming much more obtainable, to where we can typically provide that same thermal coefficient and ability to handle those environments, and be a little bit more conscious of the cost. And when we can utilize those, we do, and certainly leave that as an option for the customer. Yeah,
excellent. And Drew, I'll come to you. You're seeing stuff on the highest performance level to the daily driver folks. Do you have a preference in terms of material and those different applications?
Whatever that end valve is, whatever alloy that one is, that seems to be the best alloy for us.
Yeah.
It works really well up to, say, a 1,200 horsepower Cummins. For us, it's part number 13006.
Correct.
Yeah.
I think that's the 23.8 end version.
It is.
That's the middle of the grade that Cummins came out with.
Yeah. And it really does work really well. So that's a good example of, it's not the highest grade alloy, but I mean,
haven't really
seen any issues at all with that, as long as it's not in a 1,500 horsepower plus application with nitrous.
Yeah. How about some of the stuff that material-wise maybe you won't go back to, or you avoid because you've seen problems with it?
That's the only like exhaust valve we use.
Okay.
The intakes have all been really durable. We haven't had any issues at all.
Okay. Very good.
This is some of that great communication, because the last time we were in to see Drew, in his shop, and we were going through this because we wanted to just to make sure that he understood, what else was there.
Yeah.
And we were talking about some of the race valves and where they were going to be nitrided, and he says, look, in my basic build for my customer here that we move a lot of heads and engines, your exhaust valve works fantastic.
Yeah.
So
we haven't had to spend that extra cost really for a lot of our customers. Yeah. So there are better options, but for most of our customers, we don't need that stuff.
Yeah. Yeah.
Why over-design it? Why increase the cost to then make the sale harder on his end and his team?
Yeah, it kind of makes you a hero a little bit, right? You know,
Well,
cost saving.
We try not to spend everybody's money just,
Yeah.
you know,
Just because.
just because.
Yeah, sure. All right, guys, let's transition to valve sizes. Obviously, there's, you know, a number of different sizes these valves can come in, and, you know, obviously that's engine specific too. Drew, I'll start with you though, since again, you guys are primarily working on the Cummins stuff, but you also have different stages of the cylinder heads that you're using based on, you know, what the application is. You know, what kind of valve sizes do you typically
We can get up to like 1.5 on some of the 6-7 stuff. It depends on the bore sizes in the engine. And also increasing valve size typically does not increase a lot of flow. It helps with low lift without doing port work. So there's a lot of people that put bigger valves in, don't do any port work, and you might gain 10% at really low lift, like up to 200 thousandths valve lift, but beyond that, it's totally useless.
Yeah.
So again, it comes to one of those things where we don't spend the customer's money on that stuff without getting them into port work and so on before that.
Yeah. Yeah, and I was going to ask, you know, what are some of those differences or things that you'll see, you know, if you used a smaller valve versus a larger valve, or what are you trying to, you know, achieve if you do move up or move down?
More flow with the bigger valves is the biggest thing.
Okay.
And it depends on the cylinder head design. So some cylinder heads, like for a street application or something like that, if they don't have swirl built into the chambers, a lot of times when you get to bigger valves, you actually hurt that in the diesel stuff.
Okay.
And it actually hurts performance down low. So there's a fine line between all of those things that kind of help everything play together based on the customer's application and what their real goals are.
Gotcha. Yeah. Okay. And to you guys at SBI, you know, obviously you guys are, you know, you got valves out there for a number of different engines. You know, how many different sized valves for each engine application do you guys typically strive to have or offer?
Well, typically we're you know, obviously we're a replacement, you know, OEM replacement type of operation. So we always will have obviously the normal OEM size that was found in the application. Typically when we're getting to oversizes, you know, we did play around with a little bit of LS stuff where we would go 20, 30, 40 over. You know, it's, again, as Drew mentioned, there's only so much room in these fire chambers anymore inside the chamber. So it gets a little difficult. Then you end up having issues with, you know, the seat, the valve seat inserts having to cross or layer. So, you know, we haven't found a lot of room for increasing valve size. I think the piece that is maybe even more important is creating the flow, as Drew said, is getting some sort of swirl polish on the underhead, making sure that it's not as cast or shot peened, and fully machine the valve. Certainly can play with the seating angles and the secondary angles to try to achieve some of that, as opposed to always going larger.
Yeah. Okay. Very good. Now, guys, I also mentioned, you know, the overall makeup of a valve being a one-piece component or multi-piece component. Do you guys do a little bit of both?
Absolutely, yeah. Excuse me. Yeah, we've got, you know, full stainless or non-magnetic materials all the way to the tip, where you would have a wafer tip type of the button end that would be friction welded on. And then you also have your two-piece valves. Obviously, cost savings is the most important thing. You're only having to deal with the portion of the head up the stem where it's really exposed to the extreme environments or heat. Leaving the back half is oftentimes easier for us when you get into multiple groove valves where they've got to be hardened through the grooves. The chrome steel type of materials that are used for the back half of the valve can be annealed to any hardness we really need. 50 is typically the minimum. But when you get into these valves with the multiple grooves that need to rotate within the keeper, it allows us to penetrate and get hardness all the way through those grooves. So I think there's more that you can do with the two-piece or bimetal valve. It opens itself up to more versatility and meeting the top end. But outside of that, you know, we do our fair share of full one-piece valves where it's needed.
Yeah. And so it sounds like you guys do the two-piece, you know, more than you might do the one-piece for those reasons.
More often than not, exhaust valves are going to be the need for the two-piece valve. You know, at a consumer level or a cost point, to make a a valve all the way out of Inconel or all the way 21/4
Right.
in, where it's just not necessary.
Yeah.
So those valves are friction welded and then ground after, centerless ground after, and then any type of treatments would be added after that fact.
Okay.
Yeah, I've gotten some quotes on one-piece stuff, and it's a big difference.
Yeah.
It's significant.
And it hasn't been worth it. I mean,
Yeah.
we haven't seen failures in the friction weld and stuff like that, really. So
Yeah.
it's not worth the extra cost, really.
And then, on the intake side or the exhaust side, do you lean one way or the other, or are you using a two-piece on both?
I'm not sure if we see so little issues with the intake valves.
Yeah.
I couldn't tell you if it's a one-piece or a two-piece.
Yeah, intake valves are typically going to be one piece,
Okay.
a high chromium silicon type of chrome steels.
Yeah.
Again, gives you the ability to harden the tips, also the ability to harden the C faces, induction
Yeah.
harden the C face, to where if you are in an environment with EGR and the not quite there to get up into a nickel-based alloy, we could harden the C face of a chromium base valve and achieve some real good hardness in that area of the valve. But the heat typically just it's not there. So bringing in some of those more elaborate materials is just not necessary on that side.
Yeah. Okay. All right. And so we're talking intake and exhaust. So let's stick there. And Drew, I'll come back to you. What kind of differences do you see on the intake versus the exhaust when it comes to valves? Obviously, you're trying to achieve different things,
Right.
And there's different sizes involved. So you want to talk a little bit about?
Valve angles is one of the biggest things. Like in our diesel world, typically you have the intake sometimes is a little bit bigger than the exhaust, but most of the engines, the valve sizes are about the same or very close to being the same intake and exhaust. But most of the diesel applications are like a 30-degree intake angle as opposed to a 45-degree angle on the exhaust.
Yeah.
And we've played with that stuff on the flow bench and everything, and the 45-degree stuff on the intake will flow a little bit more up top, but typically we're losing so much on the low lift with a 45-degree that the average over the whole cycle is actually worse. And a lot of people, that's a big upgrade. Put exhaust valves on the intake side or go to 45 degrees on the intake side. It's an internet myth or whatever you want to call it, but it's not a direction we typically go because it's just not worth the additional cost and the gains. It really isn't gains when you look at the average flow. And that's what we always look at as the average flow over the whole lift range.
Yeah. And then how about for application specific? If it's high performance or if it's a daily driver build, are there differences that you're experiencing there or trying to achieve there?
Yeah, I mean, depends on what the customer's really going for. I mean, if it's a really high-end application, then we'll typically go up on sizes and everything. It's a big ported head at that point.
Yeah.
So it's a whole different ballgame.
Yeah, you're doing a whole bunch of stuff.
Yeah.
Yeah. All right. And, we can go there too, because as you get into that high performance stuff, and then you're starting to do valve jobs, you're probably changing some seats and doing different things.
Seats and springs.
I know with you and cylinder heads, I mean, you guys take that stuff very seriously no matter what level you're working at. So yeah, talk a little bit about, what you guys might change out in terms of the seat or the guide and how it interacts with the valve.
Yeah, biggest thing is valve seats. So the Cummins head in particular has a pretty small seat. So the problem with that seat is it typically, at least in our applications and what most of our customers are doing, there's not enough surface area to hold the seat in. So they'll fall out from the OE application with lots of heat cycles. So we use a larger seat that's provided by SBI for all of our cylinder heads. And then more press fit for that seat also. Guides, we do a lot of remanufacturing. So the most economical and fastest way for us is to do a guide liner. And really, they've held up really well. They typically hold up better than the original casting. And for the money, again, it's not worth spending the customer's money on a whole replacement guide for us, at least.
Yeah.
Now, if something gets really tore up, then we'll put a big replacement guide in it. But for the most part, most of it's a guide liner.
Okay.
And then springs, it just depends on what RPM range and horsepower everyone's going to.
Right. Very good. So guys, there again, seats being kind of a part of this whole deal, that's something you guys also offer. What are some of the materials of seats that, for Drew, as an example of a customer on the diesel side, what kind of stuff are you guys putting out there?
Well, typically, our Star Series is kind of a cure-all. There's not many environments that it's not a good, alloy to put into place. We've seen it run in circle track cars. We've seen it run in drag type of applications. Then we've got a whole lineup, obviously. Compatibility-wise, there's not a whole lot that won't run against the Star Series. And then you can also get up into the cobalt type alloys as well, some stellite type alloys. Again, a little more extreme than probably what is really required. Typically the Star Series is kind of the cure-all. I think that's what Drew puts in on the exhaust side, nickel-based, they're non-magnetic. And then in the diesels, typically you can get away with a high chromium or a silk chrome type XB on the intake side. Okay.
Very cool. And then Drew, coming back to you, obviously you got to do a valve job if you're going to be putting in new seats and get that stuff mated up properly. You want to talk a little bit about, what you guys do on the valve job side of things? And
we've got a new seat and guide machine, so it's like a single point turning.
Yeah.
So it's using it turns the valve seat like a lathe. Whereas a lot of the cutters have the valve job profile cut into the cutter. So the different seats and different things like that, you can get some really hard seats that are very difficult and very hard on tooling. And the seats that we use on the exhaust side are pretty aggressive on tooling, but it's kind of what we have to have.
Yeah.
There's lots of different combinations there. We start from a seat that has no angle in it or anything. We're putting the whole valve job in from scratch when we put seats in.
Yeah. And what kind of things could potentially go wrong if you're maybe experimenting with a different type of valve job, or?
It's not so much the valve job as the seats. We've had seats in the past that have cracked.
Yeah.
Not from SBI, but from other manufacturers, and we didn't see those issues for 6 months.
Yeah.
We see one head come back and it had a cracked seat in it, and you're like, uh-oh, is this a coincidence or is this something different? But a lot of that, when you don't get good communication with a vendor like SBI and making sure that that's a good fit, and then them working with you when there is something like that comes up to move forward and do better is a big deal.
Yeah, for sure. All right. Hey guys, I also wanted to, not ignore the gas side. Ryan, you've touched on it a little bit with the LS type of application. Obviously Drew is 100% diesel, but what are some of those differences when it comes to valves between what gas guys might be looking for or using versus maybe what Drew's got going on with the diesel stuff?
The diesel environment, once again, understanding how that's going to be used. Drew's shop, you're talking about a, light or medium duty setup. So this isn't, a heavy duty, piece.
Yeah.
But when he puts something together for, his upper end horsepower applications, then you've got to understand, like I said, what that environment is and how you're going to solve something that is, a potential issue.
Yeah.
So going back to your speed of a cracked seat, even though it wasn't our product, having that open dialogue and communication, whether it's somebody else's or not, what do you see, what do you experience, allows us to have a mindful set of eyes on that, to look at it to say, okay, well, what led to this? Would you think that there was a porosity issue, with the material? Obviously was not that you were going to install this proper here, but was our press fit, not correct? Did this not mate properly with the valve?
Right.
Was the margin, was there no margin, left on this? We see a lot of, not that one shop is going to do it better than another shop, but from what you reclaim to what you put in new, you got to be very mindful of that.
Yeah.
Am I going to reuse that valve? Am I going to put a new seat? Am I not? What does that seat pocket look like? So I always come back, obviously on the sales side, I want to have the best dialogue and communication as possible.
Yeah.
From the customer back to our product team, our QC department, so that we can understand, where we sit.
Yeah.
Does our stock piece work? Do we need to upgrade that to something that would be in our race or performance line? Or do we get to where we do something that is a one-off? Just because it's not in the daily 1,000-page SBI catalog doesn't mean that we can't or don't do it.
Sure.
So something that we may fix or be a one-off for Drew or another one of our business partners doesn't mean that we're going to offer that to everybody and catalog that.
Yeah.
So there's a lot on the gasoline and diesel side that make sense, that are going to work together. But then on the diesel side also gets pushed a little bit harder than our traditional stock OEM replacement, piece.
Yeah.
So that's where we really have to dig in and understand, is it going to be dimension based? Is it going to be material? Is it going to be surface finish?
Yeah.
How do we solve that problem? And if there isn't a problem, as Drew said, why over-design it, over-engineer it?
Yeah.
Don't, fix something that isn't broken.
Yeah.
Just to increase the cost, then to potentially have his customer look somewhere else.
You're right.
Now both of us have lost.
Right. No, absolutely. And not to belabor the point, but whether it's gas or whether it's diesel, a one piece or a two piece or some of the materials you were talking about earlier, all that stuff still applies. It's not like night and day.
No, very much applies.
Yeah.
We typically don't see the need to go extreme into the Inconels or the superalloys much of the time when it gets into a gasoline application. I think, at least from my experience in working with some of our customer base, the difference is really, I think, were our design, more so than material. You can get away with running 21 4-in or 23 8-in on the gasoline side, but typically you're lightening up the valve. You're making the underhead flow probably much more than the diesel guys are really after. You want the integrity left in the diesel.
Yeah.
Something there that's hardy, the underhead, the filler region is typically going to be really full, robust. And when you get into the gas side, a lot of the guys are wiping that away. They're undercutting the stem, putting swirl polishes on there. So there's not a lot of integrity left in that valve and that portion. Obviously, the geometry's got to make sense. It's got to hold together. And you also see quite a bit of larger intake valves in the gas side than you really experience in that diesel world.
Yeah. Okay.
So playing with those angles, making sure that head stays on, even though they want it neck down to almost nothing to create that flow, it can get a little tricky sometimes.
Yeah, for sure. Yeah, you don't want to run into problems because you're doing too much.
Right.
Right. Okay. Drew, something I want to come back to you about was something that's naturally aspirated versus something that you're putting boost to, because obviously in the diesel world, you got guys that are putting a lot to these engines. Does that make a difference when it comes to valves? Are you doing something different because someone's putting all that?
Not really. I mean, we do. We need a hammer, basically. We need something that'll take a lot more abuse than a typical gas engine does. Gas engines don't typically see the cylinder pressures, even that stock diesels see. So when we start increasing everything, we're really increasing cylinder pressure and firing pressure.
Yeah.
So you have to have, like he said, an undercut valve or something like that really causes problems because they start to tool up. They're just built too light. A lot of the gas world needs to build them light because they're turning a ton of RPM, but diesel fuel just doesn't work real well at really high RPM. It just gives up, just quits making power up there.
Yeah.
So that's why we have to work within the RPM range that the diesel still works in. But boosted versus naturally aspirated, a lot of people say, well, you don't need to do cylinder head flow because it's boosted. Well, that's not true. Like cylinder head flow, you're still moving the density of air is what you're moving. And you're increasing the density of air, but if you can't move it through the cylinder head and into the engine, you didn't increase the density of air in the cylinder, and that's what really matters.
Yeah.
So everyone sees big boost numbers and so on and so forth. That's just a number of restriction. A lot of times with a better flowing cylinder head, we'll reduce boost pressure, same turbo setup, same everything,
Yeah.
and increase performance
Oh, wow.
with less boost pressures.
Yeah.
And it cools everything down, cools the intake charge down. It's easier for everything.
Yeah, it's just a more efficient
Yeah.
head at that point.
Right.
Okay.
Yep.
Very good. And Phil and Ryan, how about on your side? Again, when you're looking at something that's maybe naturally aspirated or something that's got boost or daily driver versus high performance, what's really those differences in materials? Is that due to the heat involved, or are there other factors that make you guys go to a different material than you otherwise might?
I think Drew is probably, again, the guy to speak on some of this. Within our organization, we're really fixed on OE repair, replacement. And so that's why I say it's always a good opportunity to partner in with some of these the performance guys who think on those levels.
Yeah.
Certainly materials, obviously everything. If you're going to seat pressure, the harsh cycle of the valve potentially, depending on the cam setup and how much they're really running these things up, the profile. We're typically called in to work with someone who's got an issue. And so from scratch, we don't do a whole lot of development, in that vein. So we're usually there to try to solve someone's issue as opposed to just going out and trying to, solve something on our own.
Yeah.
Typically it works for us. The OEs are never going to have a problem. The typical reman's never going to see an issue because we've taken that times 2 or 3 or 4 or 5.
Yeah.
And it survives here, so these guys can be super confident that it can go anywhere.
Yeah.
And they're not, like, if you've torn this up or you tear this up, you did something dumb.
Yeah.
So
Right.
at that point.
Yeah, and so let's have a little bit of fun, right? Like, you guys have seen, all of you guys have seen stuff just get messed up for one reason or another. What are some of those things that you've seen, folks just do wrong and you end up tool-looping a valve or, bending a spring like we were talking about, before the cameras got
Tune-ups,
rolling?
injector failures, fuel system failures. Well, my valve's messed up or my seat fell out. Well, did your seat fall out because of an injector issue that caused that problem? Like I said, some of the Cummins stuff had issues with seats falling out and they were a smaller seat.
Yeah.
So that was a common problem. When those things fall out, they just obliterate everything.
Yeah.
It goes and crunches the whole engine. I've seen it ruin the blocks and all of it. So we're proactive on that. We put a bigger seat in from than the factory stuff is when we do even just our basic reman cylinder heads, because I don't want to have to worry about that. And it's the same thing. It's been something that's been developed from the performance side that we bring back to the OE in the stock trucks.
Yeah. So it's just guys, putting too much fuel to it or too much boost or
typically. And then there's some, like in our world, we have guys with just the regular stock Cummins trucks that try to pull 40,000 pounds all day, every day. And the cab chassis trucks were detuned from the factory for a reason. So they take a regular pickup truck and try to pull 40,000 pounds with it all day, every day. It's not meant for that. Like, it's still 410 cubic inches. If you're pulling that kind of weight all day, every day, you need a big truck. That's what they're designed for.
Yeah.
And the Dodge pickup, a 1-ton Dodge pickup's meant for a guy pulling hay bales out of the field through the summer. And some of these guys are just abusing them big time. Well, it's a Cummins. It'll do whatever. But that's not necessarily how it works.
Yeah. Yeah. Very good. Ryan and Phil, I'll come to you guys. If there's one or two things that you want viewers to take away, whether it's about the SBI product or about valves in general, what's that one or two things that, guys really need to understand when they're selecting a valve or putting a valve in? You want to kind of weigh in on some of that?
Well, I think, as time has gone on, especially when you get into the heavy-duty world, there are so many different combinations with the critical build list or the CPL of some of these applications to where the SBI catalog may have 4 different options within that application itself. I think really understanding when you tear the engine down, making sure if you find any type of identification codes, top of head, like Drew says, Cummins typically are really good at it. They either have an N or an O. Some of the other manufacturers have dots and different things to identify as to what material is supposed to go back in.
Yeah.
You might be working on, again, and that's the opportunity as well to upgrade something. More often than not, they are the same size, and you can just go up the next level and get something a little bit better put it back together. But I think, again, paying attention to what you take out and make sure you put at least the equivalent back in.
Yeah. No, seems like common sense, right? But, it's easy to not do it.
You'd be amazed how many calls we get, and I'd say, well, what did you take out? Look at the combustion face of the valve.
Right.
Well, they're in the trash, or they've been scrapped. And so, well, then the best secure thing you can do is go with the highest graded replacement piece to go back in.
Yeah, yeah, absolutely.
And a lot of times, what is going to be hard-faced and what isn't going to be. When you talk about having stellite on something. So not to circle back to the same thing each time, But as Drew was saying, necessarily, how is that going to be used as well?
Yeah.
Is he hauling hay bales, or is he trying to pull 40,000 pounds, 6 days a week?
Yeah.
And what that environment's going to look like.
Yeah. And Drew, similar question on your side. You're approaching it from a different level than these guys are, but talking to maybe peers or potential customers out there, what are some of those key takeaways?
Biggest thing is communication. Working with a company like SBI to move things forward and to solve the problems that we've run into. Like we had a spring issue with another manufacturer that we've gotten the same spring for years, and they've just gone downhill on quality. So we reached out to SBI to work with us on stuff like that. Can we get the spring manufactured? Can we get a better piece than what we've had that still meets the same requirements for valve lift and seat pressures and over the nose pressures and all that stuff? And working with people to solve those problems is a big deal.
Yeah, absolutely. And again, we were talking off camera a little bit about the spring stuff with you and working with SBI as being a future product. So again, looking to the future of valves and seats and all that stuff that's integrated into it. Where do you see some of this stuff going? Ryan, you were talking a lot about some of the alloys and the materials involved. Do you see it continuing to evolve? Certainly, performance isn't going to go away. It's people are going to keep trying to one up themselves and each other. So
everyone's going to be looking for the next best mousetrap. At the end of the day. Well, with regard to like a valve spring, and we're talking about materials and where we're going with that, the requirement for materials is probably the fastest race, depending on what valve spring raw wire material they have to offer. Understanding that what that spring's going to go through, and having the feasibility studies and reports from our engineering teams. In this instance, at its basic design, really wasn't the best design when we're trying to achieve what these guys want to pull out of this spring. So to increase the material, upgrade the material, get an additional coating with nitride, the gas nitride process on top of that upgraded material, really is going to be the answer to go forward with that.
Yeah. But again, I assume you're still looking at something that's economical, is right for the application without being, crazy. What are some of those factors that are just, no matter how far into the future we get, you still have to consider, right?
Right, you still have to consider cost. At the end of the day, you have to be able to come to market at a price that's reasonable, or you just don't sell anything. So the cost can't be completely out to lunch. So you have to balance that with what you need. And some of the suppliers like that those guys work with are used to dealing with, they can do tests where they can run the valve spring on 1 million cycles. A lot of the aftermarket performance valve spring manufacturers don't do that. So it makes a big difference when you're starting to look at some of that stuff for having some peace of mind when you're buying a lot of valve springs.
Which is what we did in his case, well. So starting, as Ryan said, we took the spring to reverse engineer it so we could understand what characteristics it has. And then from Drew saying, this is going to be the operating environment that's going to live within. And then how do we change that? And right away,
I didn't know SBI could help with that. It wasn't until these guys are standing at my at the front counter, well, we can help with that. Oh, well, cool.
So, which is that open dialogue. I always come back to that communication. You get used to your thought process, your buying pattern, and what you do, with the people that supply you product. That you may not think outside of those lines. And just asking one simple question, or us being able to see one piece. Then it brought, our sales manager and I, then we just started with a barrage of questions, for Drew. So, because our eyes opened and we thought, we can really help fix this for him. Let's be a part of this together. But you do it the right way. Your first steps need to be your best steps. So reverse engineer that, understand what the current characteristics were, what we need to upgrade. And as Ryan had alluded, we had to do, 2 different things. Not only did the material need to be upgraded, but a surface finish needed to be applied to that. And that was given to us from, our manufacturing facility. And when they run the feasibility test, they're not going to make something that they don't believe or will not stand behind.
Sure.
So when they say, look, you have to do this for this to live. And when we say live, and it's only for a certain amount of time as well, when you push that.
Everything fatigues. Yes.
Correct. Even if you use, when we were talking about valves and super alloys, yes, it's going to take, you had mentioned heat earlier, and heat is always the devil. I mean, that creates a ton of issues.
Cycles.
I mean, it's hard.
Yeah.
Heat, cool is extremely hard, on the metal.
Absolutely.
But just because you upgrade to a super alloy doesn't mean that you're okay for eternity.
Right.
And I never have to look at this again.
Right.
I wish it worked like that, but it's not that simple.
Sure.
So finishing that spring, after we made the needed upgrades to this, then the feasibility says this is what we're looking for. Well, then you run it through 1 million cycles, which is what we did for Drew Spring.
Yeah.
So gives you a lot of confidence in doing everything the right way and following all of your steps to be successful to fix the issue that he had come across.
Yeah. Yeah.
But if we didn't have that communication, I said I always come back to that, and I guess that's the sales side.
Right.
If we don't have that dialogue and we
yeah.
can't talk freely like this, or we don't take the time, more importantly, on our side to ask Drew, well, what happened here? Oh, what's that broken spring over there? What the heck is the head doing off that valve?
Yeah.
Nosing around his place is what they're up to.
Pretty much.
Well, we tend to put a lot of tore up parts on the counter.
Yeah. Well, you're right.
So when you have a piston sitting there with a valve head in the top of it and a seat in it, what happens?
Well, your entryway has
It's a talking point.
Right.
Your entryway has a blown up engine, yeah. So.
Yeah,
He's
our
got
entry
some
does.
very cool stuff on his front counter. So.
Starts with yes, we've destroyed it. Anything that can be destroyed on a Cummins, we have done it. Multiple times.
All for testing, though.
All for testing. But that's what gives us a better product each time. It's not like if we do tear it up, okay, well, what do we do to fix it?
Yeah.
And how can we move forward from that? It's never like not moving forward. That's the thing. And working with a manufacturer that can help you move forward is a big deal.
Yeah, and again, going back to valves and forward thinking, diesel in particular is just progressing every year, every few months. Like,
Yeah,
it's
the
kind of-
new
it's kind of
the new
blowing-
6.7 Ford Power Stroke is 500 horsepower and 1,200 foot-pounds. Like
it's crazy.
OE.
Yeah.
So that has to have better components in it than the last generation did. And it's happening with everything, especially the gas world, all the EcoBoost engines and all that stuff too.
Oh, small displacement.
Yeah, small displacement, more horsepower out of smaller displacement to get better fuel economy when they're at light loads and all that stuff is a big deal. So it's making that valve technology that is probably coming out of the diesel world into the gas world more because now they're seeing that kind of abuse at that level.
Yeah.
So it's not just in the racing, it's in the OEs. The OEs are doing it too. I mean, they're trying to make everything smaller, lighter weight, and do more all the time.
Yeah.
It's never ending.
Yeah. Well, again, going back to what Phil said, it's good to have a relationship like what you guys have and are able to talk about things that you're seeing and experiencing, and then these guys are working on their end to, meet or exceed OE levels for everything and give you guys a product that works. So, excellent. Guys, before we sign off here, anything additional that we didn't quite hit on or anything else on your mind when it comes to valves or things guys should know about valves or a seat or anything like that?
Not a whole lot. I mean, a lot of times they got to think about what the valve's doing and how fast all that is happening. Like, how they got to realize that valve's opening and closing how many times a second.
Yeah.
Like, it's amazing it even works.
Absolutely.
Yeah, it blows you away when you watch the process.
Yeah.
Like, when you really think about it, it's like, how in the world does that, how does that work?
Yeah.
But it does, over and over and over again.
Absolutely.
And the work that spring goes through?
Oh, man, all of it. Like, it's just, especially the valve, like, everyone just takes valve train for granted, but when you start thinking about how many times a second that thing is moving up and down and combustion pressure on it, and it's
tortured.
It's crazy.
It's incredible.
Yeah, it is incredible.
Well, guys, really appreciate all three of you being here in studio today. And as always, we appreciate you guys watching this episode of Intellectual Horsepower. Make sure you're checking out everything that Drew's got going on at D&J Precision. And of course, make sure you're checking out everything going on at SBI and the valve train products they offer. Again, thanks for watching, and we'll see you guys next time.